Thank you, Alex, and welcome to the webinar. We're here to talk about CamWorks for Solid Edge, so let's go ahead and get started. Geometric is the company behind CamWorks for Solid Edge. Geometric is a global company with offices all over the world. And in addition to CamWorks, we also market a number of other software products, including NestingWorks, DFM Pro, Glovius, and others. And in addition to the software products that we market, we're also one of the world's leading providers of software development and engineering services, as well as manufacturing engineering and automation services. CamWorks is part of the Geometry Technology Solutions, and in this diagram on the left you can see the software products that we market for design. In the center are the software products for visualization, and on the right are the software products for manufacturing, including the CamWorks product. My name is Mark Bissell, and I'm the Senior Applications Engineer for Geometric, and here's a little bit about my background. So moving on, let's talk about why CamWorks. CamWorks for Solid Edge can help you reduce your programming time by up to 90%. The design and manufacturing models become one and the same, and we can help you to capture and reuse your best practices. We can also help you cut your setup times in half. CamWorks Virtual Machine allows you to virtually prove out your CNC programs. It's a true G-code machine simulator with full collision detection, and it helps you avoid collisions and increase your program integrity. CamWorks can also help you achieve faster cycle times and double your machine capacity. You can reduce cycle times by as much as 80% and increase your tool life by as much as 500%. As we see it, the key to faster time to market begins at the top of this diagram using AFR or automatic feature recognition to automatically recognize machinable features on parts. Once the features are recognized, we can then apply the machining best practices using knowledge-based machining. In addition, because the design and manufacturing models become one and the same, CamWorks for Solid Edge will automatically adjust tool paths to design changes. CamWorks for Solid Edge is seamlessly embedded inside Solid Edge, so you never have to leave the familiar Solid Edge environment. CamWorks for Solid Edge works exactly the same with imported models as it does with native Solid Edge files, so it's also compatible with CAD files from a variety of other CAD systems. And it also supports industry standards like STEP, ASIS, Parasolids, IGES, and others. CamWorks for Solid Edge is a fully integrated CAM system, and that's what makes it different than standalone CAM systems. The CAD and CAM model become one and the same, and all of the CAM data is stored directly inside the CAD file, in the case of Solid Edge, the .par or .asm files. There's no extra files to maintain, and no issue with geometry or translation errors. And most importantly, toolpaths created using CamWorks for Solid Edge will update automatically to the design changes. This accelerates the research and development process and also reduces scrap by making sure that you're always machining the current revision of the part. CamWorks for Solid Edge is a parametric feature-based CAM system. It uses true 3D machinable features, not 2D chains and profiles like obsolete standalone CAM systems. And it can automatically recognize turned features as well, including ID and OD turned features. CamWorks for Solid Edge also has a feature tree to manage your machinable features. And it will also create multiple setups automatically for parts that require machining on multiple sides. Now let's talk about automatic feature recognition, or AFR. Automatic feature recognition will automatically recognize over 20 different types of machinable features, not just holes, but also slots, pockets, bosses, and other types of machinable features. It'll create fully associative machinable features, so if the model changes, the toolpaths will update automatically. And it uses true 3D feature-based machining. The end result is faster programming as compared to traditional CAM systems by up to 90%. CamWorks for Solid Edge will automatically recognize OD turning features, ID turning features, and a variety of prismatic milling features. CamWorks for Solid Edge also uses the world's most advanced knowledge-based machining. This is true knowledge-based machining. It's not just an add-on, but it's the way CamWorks works. It allows you to be able to capture and reuse your best practices, and it's fully customizable so it can become an expert database for your own company. And it eliminates repetition and promotes standardization. And this is some of the most advanced technology that's available. Now let's take a look at a live demonstration of CamWorks for Solid Edge. Let's begin by taking a look at this aluminum plate. Once CamWorks for Solid Edge is installed, a CamWorks ribbon menu is added to the Solid Edge interface. In addition, 3 tabs are added to the command bar, one for the CamWorks features, one for CamWorks operations, and one for the tools in CamWorks. Notice that I already have some tools defined, and you can predefine a tool crib with the standard tools that you'd use on each machine. Now let's begin programming the part by using automatic feature recognition to automatically recognize the machinable features on the part. You can see how quickly CamWorks for Solid Edge was able to automatically recognize all the machinable features on this part. It created a part perimeter feature to mill around the outside of the part, a face feature to face the part off. The next feature is a hole at the center of the part, which happens to be a different size than the rest of the holes in the part. Next, we have a hole group, and you notice that all the small holes have been grouped together automatically in order to create this hole group, so that I don't have to go around and select each and every hole in the group. Next, we have the group of counterbore holes, and then you can see a feature has been created for each of the irregular pockets around the part. Now that all the features have been created, I can go ahead and generate the operation plan in order to machine these features. Knowledge-based machining is used to automatically generate all the machining operations for the features in the feature tree. Once the operations have been generated, I can generate the toolpaths. The sequence of machining is always important, and what I can do is use the drag and drop capabilities of CamWorks in order to establish a particular sequence. So for example, if I wanted to face the part off first, I can drag and drop that operation to the beginning of the operations tree. In addition to the ability to drag and drop the operations into a particular order, CamWorks for Solid Edge also includes the ability to be able to sort operations. I'll open up the Sort Operations dialog box and click on the Sort tab. Next, I'll drag the rough milling and the finish milling prior to the center drilling and drilling. So this will establish a new sequence for machining. These sequences can also be stored and reused. Once I hit the Apply button, then all the operations are sorted into that order, so that we get the rough milling, then the finish milling, then the center drilling and drilling. Now that all the operations have been sorted and are in the sequence that I want, I can go ahead and simulate the machining process. Here you can see the actual machining process occurring. I can stop it, I can single step through it, I can slow it down, and there's many other options up in the Toolpath Simulation toolbar. Let's go ahead and continue the simulation and watch the machining process take place. Once the simulation is complete, I can compare the machined model to the original design model. And you can see here everything is in green, which means that the part has been machined exactly as it was designed. If there was any remaining stock, it would be in blue, and we can see some of that on the bottom of the part. And if there's any gouges, it would be in red. Now that I'm happy with my program, I can go ahead and generate G-code. I'll go ahead and select the G-code icon and then give the program a name. I can then go ahead and step through the G-code or just hit play, and we can see the G-code being generated to machine this part. So we've been able to program this part in a little under 6 minutes. Let's go ahead and take a look now at how easily we can make changes and how the toolpaths will update automatically. Let me go to a top view of the part, and then let's use Solid Edge's synchronous capabilities to make a change to the part. I'll draw a window around these features, and then I'll go ahead and offset them. And then let's just type in a value here of say 15 millimeters. Notice how dramatically the part's changed. When we go back to CamWorks, as soon as we touch one of these tabs, we get a message. CamWorks knows that the part's been changed, and it's asking us if we want to rebuild it. The light rebuild here is if we made a change that didn't affect the toolpaths and we didn't want to wait for all the toolpaths to be rebuilt. Obviously, in this case, we've made a change that dramatically affects the toolpaths, so we need to do a full rebuild. CamWorks will now automatically regenerate the toolpaths in order to machine the new revised part. Now that the features and operations have been rebuilt, we can now simulate the toolpaths and watch the revised part being machined. So you can see the advantages of the design model and the manufacturing model becoming one and the same. The result is the CamWorks for Solid Edge toolpaths update automatically to the design changes. This ensures the current revision of the part is always the one being machined. Now that we've seen CamWorks in action, let's take a closer look at how CamWorks works. Let's start at the top of the operations tree with the CamWorks NC Manager. Here we can see some details about the program, including how much time it will take to machine this part. Next, going down the list, you can see the configurations. Each CamWorks for Solid Edge file can have multiple configurations and can be used, for example, to be able to have different programs for different machines, all stored under one Solid Edge part file. Moving down the list, we'll go to the machine, and in the machine node is where we can select the machine that we want to program. This could be a list of the machines in your company. For this example, I'll select the Haas VF4. There's also the ability to set up a tool crib for each machine, which would be a standard set of tools that you might use on that machine. We'll also have the ability to select the post processor and a posting tab to put in some information that might appear at the top of the program. This is a user configurable area. We'll also have the setup tab and the rotary and tilt tabs, which are typically used to set up 4 and 5 axis machines. Going down the list, then we also have the Stock Manager. By default, CamWorks for Solid Edge uses a bounding box around the part. But you can also create a Solid Edge sketch if you have a blank that you want to machine the part from. In addition, you can also use an STL file, so if you have a casting or forging that you want to use as stock, you can create that forging or casting in Solid Edge and then save it as an STL file in order to use as stock in CamWorks. Next on the list is the mill part setup. This is the setup for the machine. Here I can specify where I want the part program 0. By default, CamWorks puts the part program 0 at the center top of the stock, but I can also change that to a different stock vertex if I want to do that. For example, I could pick the upper left corner for the part program 0 and then say OK. CamWorks knows that the part program 0 is changed, and it asks if we want to regenerate the program from that new part program 0. I'll say yes, and all the toolpaths will be regenerated automatically. Under the setup are each of the operations. And let's just take a look at one of the operations, for example, of the roughing of this pocket. If I double click on the operation, it'll open, and all the information regarding the roughing of this pocket is stored within this one dialog box. Here we have the tool, and I can change the parameters on the cutting tool itself, the tool holder, the tool crib that we saw previously, and if I want to use a different tool to machine this pocket, I can simply select it from this list, and also the station number for what tool number is being used. In addition, there's also the feed and speed, and the parameters regarding the roughing of this operation. We have the NC tab to set up the rapid plane, and then some other tabs regarding more advanced functions. So using CamWorks for Solid Edge, the user can decide exactly what strategy, tools, feeds, and speeds they want to use in order to machine a particular feature. Once they've decided on the strategy, they can then store this strategy in the technology database, and it can be reused automatically by CamWorks the next time a similar feature is found on a part. The end result is parts can be programmed much faster using CamWorks for Solid Edge than they can using standalone CAM systems. So now let's take a look at another part and see how efficiently CamWorks for Solid Edge can be used to program the part. I'll switch windows and go over to this other part. Let's go to the CamWorks ribbon bar, and we'll start by extracting the machinable features on this part. Now that all the features have been recognized, we can go ahead and generate the operation plans using knowledge-based machining. Now that all the operations have been generated, let's go ahead and generate the toolpaths. And now we can simulate the machining of this part. Notice how in this example I've used a pre-cut blank for the machining. I'll go ahead and simulate the process. And now we can watch the machining process taking place. So you can see how quickly I was able to generate toolpaths to machine this part. And again, if I compare the machined model to the design model, we can see everything is in green, so the part has been machined correctly. Now I'll go ahead and generate G-code, give the file a name, and then go ahead and create the G-code required for the machining of the part. So I hope you're getting an idea of how quickly parts can be programmed using CamWorks for Solid Edge. Next, I'd like to look at a multiple part assembly. I'll switch windows, and let's take a look at this tombstone fixture with multiple parts mounted on it. So in addition to being able to machine individual parts or program individual parts using CamWorks for Solid Edge, we can also use CamWorks for Solid Edge to machine assemblies and parts in assemblies. So here, let's begin by opening up the Part Manager. The Part Manager lets us select which part in the assembly needs to be machined. So I select one of the parts that I want to machine, and then I can go ahead and add all the instances of the part rather than having to go around and pick them all. Now all the instances of the part have been added to the CamWorks Part Manager. I can then go ahead and use CamWorks Automatic Feature Recognition, as we have previously, to recognize all the machinable features on the parts. All the features have been recognized, so now I can go ahead and generate the operations for machining. And this takes just a minute because there's a lot more operations to be generated here. Now all the operations have been generated. I can create the toolpaths. And all the toolpaths for the machining of all the parts will be generated automatically. Okay, now that we have all the toolpaths and operations complete, what we can also do is sort these. And this time, what we want to do is do a little more complex sorting. So I'll go ahead and select to sort the operations, as I did before, but this time we'll say by and across setups. What this will do is minimize the number of tool changes and indexes for the machining of the part. Again, I'll go to the Sort tab, and in a similar way I'll do all the rough milling and all the finish milling prior to the center drilling and drilling. Up here I'll also specify that I want to sort by tool. So one tool will be used across all the parts to minimize the number of tool changes. Let's go ahead and hit apply. And now all of the operations have been sorted in the order that we requested. Next, what I'll do is specify the fixtures that I want in my simulation. So to do this, I'll edit one of the setups and add the fixtures. I'll just click on one of the fixtures, and again I'll add all the instances of that fixture. In addition, I'll also add the tombstone as a fixture as well. And now, when I perform toolpath simulation, we'll be able to not only see the fixtures, but also perform collision detection against those fixtures. So let's go ahead and simulate the machining process. Notice how it's using one tool on all the parts, and then it does the indexing. We can see a nice toolpath simulation of exactly what's going to happen on the machine. So notice how fast we were able to program this entire set of parts on a tombstone fixture using CamWorks for Solid Edge. CamWorks for Solid Edge is an excellent product for doing production machining of this type. Notice how it's also minimizing the number of indexes as well as the number of tool changes. And these are quite complicated parts with lots of features and lots of machining on multiple sides of the part. We'll let it finish up the simulation. And again, the user can decide exactly what machining strategies they want to use in order to create the best program. Next, I'd like to show you a great optional product for CamWorks for Solid Edge, and that's our CamWorks Virtual Machine, which provides true G-code machine simulation. And it's integrated right inside CamWorks for Solid Edge. In order to simulate the G-code, we first must post the file. So I'll go ahead and post-process the file. And here I have it set so that it'll run machine simulation once the file is generated. Let's go ahead and fast forward it so the G-code gets created quickly. And it's finished, so let's say OK now. And the integrated CamWorks virtual machine will open up a new window for us with the tools, fixtures, machine, part, stock, all ready to go. So you can see now it's loaded the tools, fixtures, stock onto the machine. We change the view so that we can turn off the outside of the machine. Let me also turn on the window that includes the G-code. And then go ahead and start performing the simulation. And you can see here now that CamWorks Virtual Machine is running through the G-code and performing true G-code machine simulation for us. And if any collisions occur, they'll be detected automatically. So this is a way that you can virtually prove out your programs before going to the machine tool, thereby greatly reducing setup time. Now let's go back to the PowerPoint, and there's a few more things I'd like to show you before we wrap it up. First, let's talk about what we've seen and the CamWorks workflow, which starts in the upper left-hand corner with automatic feature recognition, which is used to automatically recognize machinable features on a part and add them to the CamWorks feature tree. Once the features have been created, the appropriate strategy is then selected using knowledge-based machining. Once the strategy is selected, then we can generate the operation plan automatically, and then go ahead and generate the toolpaths. Next, I'd like to talk about high-performance toolpaths or high-speed machining. So CamWorks includes some high-speed machining cycles, including adaptive machining cycles like spiral roughing. CamWorks also includes previously removed material tracking for rest machining. It also includes smooth and continuous linking, and this helps improve surface finishes. In addition to the high-speed machining cycles that come with CamWorks, there's also CamWorks VoluMill, which is an ultra-high performance toolpath generator. VoluMill can help you reduce your cycle times by up to 80%, increase your machine utilization by up to 85%, reduce tooling costs by as much as 90%, and avoid broken tools, reduce your maintenance costs, and increase the life of your machine. This next slide helps show how CamWorks VoluMill is able to accomplish such dramatic results. On the left is the traditional conventional roughing process, where, as a rule of thumb, a 50% step-over was used. The problem with using this traditional step-over is that it is overly aggressive and that the cutter is not truly climb milling. In fact, the nose of the cutter is being pushed directly into the material. Because of these less than ideal cutting conditions, the axial depth of cut had to be significantly reduced in order to avoid tool breakage. On the right, you can see what we've learned in the last several years. We've learned dramatic improvements can be achieved by taking a smaller radial step over, while at the same time increasing the axial depth of cut. By creating these ideal cutting conditions, the feed and speed can be dramatically increased to remove a much larger volume of material more quickly and achieve a higher material removal rate. So in the upper left corner of this slide, you can see the ideal cutting conditions are when the contact point of the cutter is between 12 and 3 o'clock. However, typically, CAM systems used an offset boundary type toolpath for rough milling. Unfortunately, this meant during the initial cut, a full 180 degrees of the cutter was being used. The same was true with the links between cuts and when cutting acute angles in corners. Therefore, due to the increased cutter loads caused by these traditional toolpaths, the feeds and speeds and depth of cuts had to be reduced for the entire roughing process, or the cutter simply wouldn't survive. But using the CamWorks VoluMill toolpaths, ideal cutting conditions are maintained throughout the entire roughing process. This means a 4 times increase in feeds and speeds can be used, and an axial depth of cut to the full flute length of the cutter if required. So now let's look at an actual case study using the CamWorks VoluMill. A firearms manufacturer was machining titanium using a 1/2 inch 5-flute end mill. Before VoluMill, they were cutting the parts at a little over 1200 RPM and 6 inches a minute. The cycle time was 80 minutes per part, and they were getting 4 parts per tool. Using VoluMill, they were able to nearly double their axial depth of cut to 0.600 and machine the part at over 3000 RPM and 100 inches a minute. The cycle time dropped to 30 minutes, and at the same time the tool life was increased by 10 times. The end result was a 266% increase in production and a 90% reduction in tooling costs. In the next case study, a 1/2 inch 4-flute end mill was being used to machine 1018 steel. Before VoluMill, the part was machined at the cutting tool manufacturer's recommended speeds and feeds of 3200 RPM and 40 inches a minute. The cycle time was 21 minutes, and the tool life was 4 parts per tool. Using VoluMill, the depth of cut was nearly tripled, and the part was machined at 9000 RPM and 360 inches a minute. That's nearly a 3-fold increase in speed and a 9 times increase in feed. The result was an 80% reduction in cycle time, a 400% increase in production, and a 70% increase in tool life. Here's a video of the part being machined. Watch as a 1/2 inch end mill is used to cut 1 inch deep in 1018 steel at 9000 RPM and 360 inches a minute. This is nearly 3 times the recommended speed and 9 times the recommended feed rate, dry, without cooling, using only compressed air to remove the chips. CamWorks is available in a variety of machining modules to enable you to purchase only what you need. The milling modules begin with 2.5 axis. A 3-axis module is available, as well as a 4 and 5 axis module. And each of these modules include the previous modules. So for example, if you purchase a 4-axis module, it will include the 2.5 and 3-axis modules. For turning, there's a 2-axis and a 4-axis module available. And for mill turn, there's a 2.5, 3-axis, 4-axis, and a 5-axis module available. For wire EDM, there's a 2 and a 4-axis module available. Then we also have CamWorks Virtual Machine and CamWorks VoluMill that we looked at earlier. And CamWorks supports a wide variety of CNC machines. A large post-processor library is available, and users can edit the post-processors using the Universal Post Generator, or UPG, which comes with every seat of CamWorks. And of course, we have literally thousands of customers all over the world. So in conclusion, if you want to reduce your programming time by up to 90%, significantly reduce your setup time, increase production, and extend tool life, then you should consider CamWorks for Solid Edge. Thank you for attending the webinar, and if you'd like more information, please go to www.camworks.com.